Good evening, everyone. Welcome to our fifth talk in the DevFest 2024 DevFest Talk series. I'm Ruwebhi Hibat Rahman, a third-year computer science engineering student at Easy Algiers, and I'll be animating today's session. The topic for this talk is The Future is Agentic, how AI agents are driving the next wave of innovation. Our speaker, Azzeddine Chenine, is an applied AI research engineer and a Google developer expert in machine learning. He specializes in advanced machine learning techniques and scalable systems with over 4 years of experience in deep reinforcement learning. He's currently working on Deep PCB Pro, a platform that scales PCB design, and is a mentor in the Google for Startups AI First Accelerator program. Let's jump right into it. Warm welcome, Azzeddine. The stage is yours now. Azzeddine, your mic.
Yeah. Hello, guys and girls. Happy to be here today. It's been a long time since I've been into one of the GDGRG's DevFest. Thanks for the invite. So yeah, as you can see on the screen, the talk is clear. The future is agentic. I don't know if you've been into the AI saga or you've been into Twitter lately, but this word is pretty common now. You can hear the future is agentic. AI agents will take over the world, etc. And you have the right to maybe question if this is a buzzword or this is maybe one of the words companies use so they can search the stocks. But at the same time, this is the real deal also, because in today's presentation, we're gonna walk through how AI agents are basically surging from the novel AI techniques and how they are kind of like shaping the new wave of innovation that is kind of more or less gonna match or even like outmatch the iPhone innovation era that we've witnessed 10 years ago. Okay, next slide. So yeah, thanks again for the DGRGs. You can find me in Twitter or in X, as you wish to call it. I'm a research engineer and also one of the MLGTEs from Algeria. I'm also recently one of the mentors within the Google for startups, especially in the MENA region and Turkey. So before we start, we're gonna go through our plan for tonight. First, we're gonna start with the elephant in the room, ChatGPT, which is basically taking the world by storm now. We're gonna also have walked through the past decade, kind of a rewind of what the progress in AI been like for the past 10 years to 12 years. Third point would be mainly about our topic for today, AI agents and how they represent like upcoming leap when it comes to tech innovation. We're gonna walk through some of the agents that I'm happy to share with you today. I personally use or some I would personally work on. At the end, I'm keeping it as a surprise. It's sort of like a reflection on the next decade and how basically we're gonna have an Ocean Drive kind of like feeling if everything works as expected. Yeah. So ChatGPT, everyone knows what ChatGPT is. I guess everyone in the talk now is using ChatGPT. If you're not using ChatGPT, you better Google ChatGPT. And basically, I'm not like trying to hype it up. It's the hype itself. So it has been one of the fastest growing platforms human ever witnessed. So in the span of 2 months, it hits 100 million users. As you can see on the image on your right, Thread is number one, but that's sort of like stats that I don't believe in, because most of the users been acquired from Instagram and Facebook. So you can say that ChatGPT is the rank number one when it comes to the hitting number of users equal to 100 million as fast as possible. So it has been released 2022 in November. It's basically an AI assistant that can hold a conversation in text, can talk to you recently, can also like listen to you in sort of real-time fashion, can generate images, can write code. It's pretty much everything that involve daily tasks. Also, OpenAI released their API and basically developer jumped on it. Over 2 million developers is now using OpenAI API so they can enhance the experience within their app. It can be a student trying to develop a new startup, or it can be a big company trying to kind of automate their customer support. Yeah. And we need to understand the pattern here, like why people are drawn to ChatGPT. It's not sort of like a random coincidence, but it's more of like a phenomenon that attracted people to use it because the mastery of ChatGPT went beyond mastering the language, but it's able to basically solve one of the hardest tasks a human with a basic knowledge would be able to solve. For example, GPT-4 can solve problems around mathematics, coding, medicine, law, and vision without prompting or extra context. And what I mean by this is that the cognitive skills that we acquired throughout the training on a large corpus of data is basically enough for it to solve this problem. You don't have like to prompt it with books or with courses so it can solve the problem. But basically the training itself is sufficient to solve the problem. As you can see here on your right, ChatGPT is solving one of the physics tests. Even though this physics test contains images and contains text, it can reply via text. It can also generate charts because it can execute code. So basically, it's not ChatGPT generating the image, but it's writing the code to generate the image. You can see how the sort of the chain of actions done by ChatGPT is being like expanding beyond the mastery of language itself. Some people, though, saying that LLM are nowadays stagnating. I'm on the contrary saying maybe the benchmark we are holding LLM against are basically being sealed, or LLM are being basically beating the benchmarks. As you can see, ChatGPT 3.5, which is basically the first version, been released in 2022 and since 2022. And since then, we've been having incremental improvements. So we went from ChatGPT 3.5 to ChatGPT 4 to ChatGPT 4.0, and recently it's OpenAI 01. It's a different name. Some of them say that it's Extraordinary Ability 1, and we may see the Extraordinary Ability 2 very soon. So if you can see on your right, this is the incremental performance improvement of ChatGPT on the MMLU like benchmark, which is basically standing for the Massive Multitask Language Understanding Score. It's basically a set data set where you're gonna have ask questions to this model, and the model gonna respond, and somehow like you're gonna give the score for each response, and you're gonna aggregate the score and see what is the total score is. As you can see, we're pretty much beating an average human or even a human expert. And now we can question, is it basically the benchmarks being over-deprecated or the LLM stagnating? And maybe to answer this question, we need to look at the past. As they say, the longer you can look back, the further you can look forward. And sometimes analyzing the past events give you a good inductive bias regarding what would happen in the future if basically the trend goes as expected. We can say we can interpolate the future based on the past. We don't know what happened, but as they can say also, you can't like choose the card. We can just like play your best hand. So we start a rewind. Which is like 10 years of improvement in AI, and basically I try to split it into 3 factors. Each one of them is exponential, or even more than exponential. Before we start, we can explain some of the terminologies here. So if you take OM, it's basically what we call an order of magnitude. If you take 10 to the power of 0 is 1, 10 to the power of 1 is 10. So this is 1 power of magnitude. 10 to the power of 4 is 1000, which is now 4 power of magnitude. This chart here shows you the amount of flops involved in training each machine learning model. So when I try to tell you, okay, I trained my machine learning model on X flops, it means what is the computational power this model requires so it can be trained end-to-end, involving like the number of epochs, even the number of parameters and the input, etc. And it stands for the floating operation per second. Or here I would say it's the floating operations. There is a sort of a different syntax for each. And floating operation can mainly, it's an addition or it's a multiplication, okay? So if you can see here, starting from 2012, if my eyes are correct, or 2010, we started increasing the amount of flops per model, which is basically state-of-the-art model, and the factor of 0.6 OM per year. What I can call it 1.2 OM per 2 years, which is basically 5x the speed of Moore's law. So for the one who don't know Moore's law is, what Moore's law is, it's basically a law where basically we can say every computer, or in general algorithm, would double in performance each 2 years while having roughly the same cost. And we're basically going 5x the speed since 2012. Some of you would say, okay, maybe this law is wrong. Well, maybe not. Maybe not, because from 1955 to before the deep learning era, basically we're going hand with hand with the Moore's law. But since deep learning showed up and compute start going at a rate where we never saw before, basically we start going 5x or even more the speed of Moore's law. This is why somehow it's good to zoom out, because you start seeing the trend from a bigger perspective. The factor number 2, which is you are not just going bigger, but even researchers are doing their best so the algorithms themselves become smarter. And the way we can measure this is using what we call effective compute. So if you take the same algorithm and you give, we take, let's say, the same algorithm, you give it the same amount of data, and you start working on your algorithm, you're going to see that given the same amount of compute, you're going to exceed the performance you had before. Or let's say you're going to reach the same performance you had before with way less compute. As you can see on the picture, this is an interpolation of what amount of flops would take you to reach 80.9 accuracy on ImageNet dataset, which is a well-known dataset that we used to train at the start of the deep learning era and frameworks, 2015, 2016. So basically here, if you look at the amount of flops that would take you to reach 80.9 accuracy in 2012, and you compare it to 2021, you can see that it's around, so we went from 10 to the power of 22, I think, to 10 to the power of 17, which is 5 of magnitude in 10 years. So it's more or less 0.5 order of magnitude per year. And it's even way more if you take a different model, which is a vision transformer. It's 1 order of magnitude per year. So actually we are not just going bigger when it comes to compute or scaling, going crazy in terms of order of magnitude improvement per compute, but also we are going in a rate of 1 order of magnitude also when it comes to algorithm efficiency. This third factor, which is data, the lifeblood of AI. Basically now we are living at an era where we have an abundance of data. As you can see here, this is the amount of data generated each year. And the funny part here is that if you look at 2 years before us, which is the past 2 years, 90% of data generated across all of human history been generated in the last 2 years. And this trend would continue. And 50% or even more of this data is unstructured data. So it's video. But the good news is that these models are also having multimodal capabilities. They can train on videos also. But it's not as famous as, I would say, the pipeline that train on text. So this has a real issue or has an impact on the training of LLMs, because even with this exponential rate of amount of data generated, we're actually running out of data, which is weird. So more or less, if we continue with this rate of scrapping data from the internet and training on text data, although most of the data on the internet is rubbish, sorry for this word, because basically you are looking for quality, but sometimes quantity has sort of a quality of itself. So now if you look at LLM3, it's basically, they say that being trained on the full internet, for the text data we do have on the internet, including duplication. And if this rate of crawling data and training models on these data, on like public available data, continue by 2027, 1 year plus, minus 1 year, we're going to run out of data. This is why you're going to see companies like OpenAI rush to private entities like Times and other like historical companies where they have like big archives of data, and they try like to have partnership with them so they can acquire this data. So now we listed 3 exponential factors that are contributing to the age of LLMs, or I would say large language models, as they like to name them. And this has what we call a compounding effect. You are compounding now 3 exponential factors, and you can see now most of the tasks that we use to benchmark LLMs on are basically being sealed. But there is one thing. As you can see here, there is the last part, which is complex reasoning. We are not there yet. And this is the main, I would say, the inflection point when it comes to our talk today. Before we start, I wanted to remind you about a concept that you can find reading this book, which is one of the best books, I would say, to read, which is Thinking Fast and Slow, which is System 1 versus System 2. In our brain, we do have System 1, which is basically reactive. When you ask someone 1 + 1, it's 2. It's sort of a reaction. But once it goes to 81 multiplied by 751, now it's System 2 because it's not sort of like an impulse that's going to go to your mind and you're going to give an answer directly. Some people can do that, but those are like an exception. And one of the famous puzzles, they say, let's say you have a bat and you have a ball, and they tell you that both of them cost $1.1, okay? And they will tell you the bat costs $1 more than the ball. They found that 90% of people say that the ball is $0.1 and the bat is basically $1, which is basically wrong. And to solve this, you need like a math equation that we like feel free to use it or not, but at the end it's $0.05 for the ball, and $1.05 for the bat. So in another term, what I'm trying to share with you here is that the current AI excels at intuitive and reactive tasks, much more like System 1. But when it comes to System 2 task, I wouldn't say it fails. It can answer some of the problems related to that, but it comes short sometimes. And the goal of agents is how we can build on the current capabilities of LLMs so we can solve tasks that are complex, goal-oriented, and that mainly require interaction with the environment or the user. For example, I can tell an agent, plan a family trip to Santorini, Greece. But this would require somehow situation awareness. You need to check the weather, you need to check the real-time price of the flight, the hotel. Maybe you can check my bank account, see if I can afford this flight or hotel based on my preferences. Talking about preferences, you need sort of a personalized plan, like the diet that you are using, halal food, let's say, for example, or you have like some people in your family that require a certain diet, preferred activities, past travel preferences. Am I into some of the activities? Am I not into some of the activities? And also, once you go through all these steps of figuring out what is the best plan for me, then you need to provide me with a clear summary and an easy to follow step by step. And I can question that plan and go back and forth, try to ask the agent to do this and that. This is not kind of like a System 1 kind of task, but it's more of like System 2 that requires sort of adaptability to the environment and also a way how to reason based on memory and past experiences. So now we are like jumping into the AI agent field, and it is what we call the upcoming leap. So if we want to define what is an AI agent coherently, we are moving now beyond the traditional AI. We can say that it's an autonomous system capable of perceiving its environment, making decision, acting towards a common goal or towards like a specific, I would say, task that you provided with. And basically this task is complex. This agent is not like basing its decisions only on the cognitive abilities it has based on the training or large corpus of data or images, but it can use tools. It can talk to external system. Let's say it can call the weather API, call the API of your bank to see your account balance, or it can even like access a computer. It can like execute code or like talk with an environment. It can be a simulation environment. Let's say you're gonna like simulate a self-driving car. Maybe these agents can drive this car and can provide you why they make such decisions. For example, you can question why you are speeding up. He can like answer back to you, and vice versa. Okay, so I'm going briefly now to explain what are some of the sort of the techniques we use to unlock these capabilities. And each one of them is a feed by itself, but we're gonna just skim through it. So one of the main one, which is the eldest, it's basically reinforcement learning, or I would say the modern version that people like to use now to train LLM to this, which is reinforcement learning through human feedback or via human feedback. So throughout the last decade, reinforcement learning been mainly based on a reward that you craft and you kind of like a tweak. But now it's more of like do reinforcement learning, but align it with what the user would prefer. So as I said, it's align models with human preferences. You have multimodality, as I said. These models or these agents can take images, can take videos, can take text, can take code, and can take even like voice command and like real-time voice response. Also, we have long context length. You hear some of the Google products like Gemini offering you 2 million tokens in the context that you're going to provide your LLM with. Basically, these tokens act like a memory for your LLM. So it can allow you to put provide your LLM or agent with sufficient context, which is like expressed via tokens, in order to solve this task. You have two. So for example, these agents can now be adapted to talk to APIs. The API developers will start like changing their product. If you do have, let's say, a web-based platform, now you're gonna provide it as an API, so an agent can talk with, not just a developer that can call the API for. You're gonna have also chain of thoughts, which is basically if you do have a task, can I break it down into a list of subtasks that I can execute, which is basically system to intuition. Once I provide you with a big task, the first thing I'm gonna do, what is my action plan? How can I like tackle this problem? I'm gonna do A, B, C, and up to D. You have what we call scaffolding, which is basically if you do have a problem, and basically sometimes you need a group of people, right? So you need someone who's gonna act as the one who's gonna propose ideas, the other one gonna critique these ideas, the third one gonna coordinate between these two people. You can have multi-agents, I would say, spaces where basically one agent acts like a critic, the other one acts as the agent that would break out the task into subtasks, and the third one would try to coordinate with them. So you can see the horizon of the ideas that we are applying to unlock agent capabilities. Most of them are coming from kind of intuitions, so we can mimic how the human think. This is why I advise you to read that book. It's really like would align your perspective on what to expect when it comes to the research that would unlock these agent capabilities. And this is not just talk, but it's actually working. And it's even like helping, let's say if you take a model, train with a large corpus, and you apply these techniques. So these are more of like test time. So some of them, which is, let's say it's chain of thoughts, and those called scaffolding, is test time algorithm. So you are not running them when training, but you are taking the model as black box, try to apply that to them, to the model. You can get up to 30x improvement taking the same model, as you can see on the right. If you take the log 10 of 30, then it's basically 1.4 order of magnitude using the same black box model, but by just like tweaking the algorithm you're using, which is extraordinary, I would say. By the way, don't worry about these charts. At the end, I'm going to provide you with the QR code. You can scan it and go to the presentation. We're going to find a link for each of these charts. If you want to look at it further. So some of the AI agents that I wanted to name, and they are like being now used by or like hyped up by people. The first one, which is Cursor. I wouldn't say use it because I think it's gonna make you lazy a bit, especially a student. But it's a good one. It's even like further expanding upon like Copilot. So you have a code base. It can understand the code base. It can point you to some of the files within the code base. Tell you use that. You have this function already defined. You can use it. You can chat with it and to express your task. That let's say I want to implement a middleware where I want to authenticate the user. The problem now, if you do that with ChatGPT, you need to go copy paste your database definition. Now you can do it directly here while chatting with the agent because the agent already has access to your code base. You have what we call MindTrip, which is basically a solution for the problem we expressed at the beginning, which is basically a trip to Santorini, Greece. Now you can like chat with your LLM, so you can plan a trip, and it provides you with the prices of hotels, prices of flights, and even what are the most, I would say, most like what are the good activities that would resonate with you based on your preferences if you visit this place. At the end, I just want to bring this. I'm not saying it's one of like the most used, but it's being now like taking sort of an inflection point. It's a product that we are working on at InstaDeep. It's called the PCB, and it's mainly an AI agent for PCB design. We've been working on that 5 years now. At the start, we didn't see the horizon coming when it comes to agent capabilities, but now it's taking up. Yeah. And going to our final points for today, we are around 30 minutes, so we're going to have enough room for questions. It's basically, you need to hold tight because the ocean has its own drive, I would say. And let's go back a bit. So it's GPT-2 in 2019. We had GPT-3 in 2022, which is an elementary schooler. We had GPT-4 1 year ago, which is a smart high schooler. We had an L1. It's an improvement upon GPT-4, but I would say it's a sub-PhD level. As of now, we don't know like what people can do with it. Maybe it's a PhD level like model. And now let's think together. What would be the shape of the models that are going to take place within the next 10 years? Because now we are like into the field. 10 years ago, we were young. We didn't expect what we have now, but as of now, we do have the rights, so we can like try to extrapolate what would happen in the future. And the way we can do that is by also do the compounding effect that we've went through the previous slides. So what we said is we do have an abundance of compute. It has like an order of magnitude improvement that is scaling. I remember we said it's around 2 orders of magnitude, if I'm not wrong. But this is basically the chart that would express that. We said that we do have algorithmic efficiencies with also X order of magnitude. So we can add that on top of the compute. And we also said that there are some of the algorithms that we can use so we can unlock agent capabilities. And that would add us, I would say, 2 to the 3 order of magnitude. And now if you sum up all of these order of magnitudes, or as the report of situational awareness report by Leopold Aschenbrenner, I invite you to read, we can have AGI by 2027. It sounds crazy, but I think it's good that we dare to dream, and not dream, but like put the work on, because this is basically the trend, and ideally we should trust the trend. I know some of you, even me sometimes, I tend to doubt this. They say the back mirror is always clearer than the windshield, right? So if everything goes according to the trend, then probably I would say by 2028, we're going to reach having an agent at the level of an AI research engineer doing basic tasks. Or we can even exceed that. If we go to 2040, we can have not just AGI, but something I don't know how to express it would be, because I don't know what would be the what will be the shape of the tech field that these agents would gonna operate on. And finishing with this slide is this does always strike me is Cleopatra is basically living closer to the launch of the iPhone than the build of the first pyramid. So now if you can compare the rate of improvement of humanity, if we can say that the first pyramid was built in T0, Cleopatra was born in T1, the iPhone was launched in T2, then basically if T1 is closer to T2, it means that we are going at an exponential rate. And if this exponential rate would continue, then basically we are at the inflection point there. The small guy is sitting. So we don't know basically what would happen in the 4 years. We can have it all, same as we can be doomed by our sort of hyped expectation. But I would say the best bet now is to bet that AGI gonna happen, and so we can put the work on, and hopefully we're gonna be there. As of advice to the students, I think now everything is collapsing to using AI. When I was a student, some people were doing AI, some people were doing software, some other people were doing IT. Now AI is sort of eating everything. AI should be the default software now. When you think software, you should think AI. And I would love if we can acquire this way of thinking so we can keep up with the acceleration that we have. One of the examples is that Thomas Edison, for example, promised to light up all New York in 5 years. All the electricity wasn't invented at that time, and he did it. Now we have people or company CEO promising that we do have AGI in 5 years. They have an abundance of compute. They have an abundance of money. VCs, venture capitals are throwing money on them, so they can get us there without even a plan to get return on investments. But the bet that we're gonna reach AGI is, I would say, largely sufficient, so we can put the money and put the effort, and so should the student when it comes to using these tools so they can unlock agent capabilities. At the end, what I wanted to showcase here is that most of these stats being taken from the Epoch AI report, also from the situational awareness report. It's a long one, 150 pages. It goes through the geopolitics, the compute, the abundance of money or that we need to have so we can reach AGI, the $1 trillion cluster that we need to build. Electricity is a problem also here because all these GPUs you need basically to power using electrical plant, and we do suffer when it comes to that because we don't have maybe the resources to have all this electricity to build say a trillion training cluster. Some of the books I would recommend is Hands-on Large Language Models by J.L. Hammer. He's a famous, I would say, engineer working at Cohere. It has a famous Transformer blog, but now you're going to have all of these visuals within this book, so I highly recommend it. The last book I would recommend that would be sort of a daily read, which is Thinking Fast and Slow. You can scan this QR code, so you can have this access to this presentation. And yeah, if any questions that I can't answer now, you can always reach out via X. I'm happy to help. Yeah, so at the end, thank you. We're happy to take questions.
Now we will pass to Q&A. It seems like there are a few questions in the chat. First one is saying, how can AI agents get continuous updated data using MLOps?
Okay, so if understood right, then basically you are saying that AI agents need to have up-to-date data while they are running. It's more of a technical question. I would say there are a lot of framework now that would make it easy to build such data pipeline, and most of them are not I would say something that you would build from the ground up. These patterns already exist, and most of them you're gonna find already built framework that kind of plug and play. Some of the data framework that I would recommend to build such data pipelines is Ray. So you do have like a framework called Ray. And basically you can have other frameworks that are comparable to Ray, like PySpark, Apache Arrow, that are mainly meant for handling real-time, like say, data pipeline, or even pipelines where the latency should be low and the throughput should be high. So I would recommend that one. Yeah, I hope this answers your question.
The second question is saying, is it safe to invest time and money with cheap artificial general intelligence?
That's a good question. Sometimes I think of that, like, I would say, like, we can cure poverty in the world if we invest that money, but you know, it's not always fair. Is it safe? I would say, like, if we go back to the past in 1945, we had the nuclear power coming from the US, and then like the Soviet Union took out the nuclear power also. And basically that sort of equilibrium of power guaranteed that we don't have like World War III anytime soon. So if you do have, let's say, only a portion of like the world investing in AI and the other people, like including our region and all of the, I would say, the Eastern region, not investing in AI, then basically that wouldn't be safe. The way this would be safe is if every nation would have its own AI, its own like compute. So now if you're gonna see one nation putting all the money, even if that thing is not the most productive thing to do, like putting all that money in a shorter term without calculating the risk, you need also like to hurry up so you don't like miss the train. So you need to put the money on like within this engine of AI also. I would say on the long run it would be safe to put that money in. I agree, but it's unfortunate that we can't put it into some other like field, as I said. Yeah, I hope that answers your question.
There is another question saying, when you said artificial intelligence is the new software, does this mean software engineers need to know how to use AI or to work on developing AI?
So this is also a good question. When I say that, so, like AI is the new software, is like if you look at 6 years ago, you're gonna see someone claiming at a VC meeting that he has an AI-powered app. Okay, that would be enough of like a barrier of entry that you say I'm using AI. Now everyone is using AI. Okay, you can say I'm using AI, so I deserve your money and I can return this money back in 5 years. It's basically, okay, you need to use AI. What you're gonna use as a software stack on top of this, or what problem you are gonna solve using AI. As a software engineer, what you need to do first is basically understanding what AI should help you with on your daily tasks. So you become user yourself. And if you want to go the extra mile, it's basically you start digging through that black box bit by bit, like using it as a black box, seeing what are the APIs that I can use. For example, you can use the Gemini API or the OpenAI API if you wish. You can see how can I add some AI features to my app. And then you're gonna see, okay, I'm now comfortable understanding what AI serves for. I'm starting with the why. Now I'm gonna go to the how these AI tools are being built. Understanding that would be sufficient. Sometimes you need to do it yourself. Sometimes I understand we don't have the compute or the capacity to implement these models, but you can at least understand how these models are being built, what are the requirements that would give you that would sharpen your understanding of even the AI API. Let's say we're going to use an API that claim that you're going to have, let's say, 5 billion parameter models, and another API saying that, okay, I'm going to give you half the performance with 75% or 74% less parameters. One would say, okay, this has like the best performance. I would take it in terms of like a score within some benchmarks. The other one who understands AI better would say, okay, this model is smaller, so it should execute faster. I'm gonna have a high throughput, low latency. I can basically iterate and use a chain of thought. So I get more of the model just because I'm using, let's say, I would say more iteration when it comes to answering the question, and probably cheaper. So understanding how AI models are shaped under that black box or within that black box would be good skills you can acquire. Yeah, how that answer your question?
There is another question saying, what's the trade-off or the balance between tools and prompts provided to the AI agent, since it's built upon both? And when tools are missing, can we rely solely on the prompt?
What I mean by using tools is, so the prompts basically, when you're saying that I'm going to give a prompt to the agent, is as if you are saying that I'm going to put some clarification within that prompt to the agent on how to solve this task. This clarification can be, let's say, documents you dispose of that contain valuable information, but you don't know how to store them. Let's say what we call now right. So you take what is the document that would help me most answer the question and put it in the prompt and try to answer the question. But when it comes to the tool, it's more of like, okay, this agent, let's say, needs to know what's the weather temperature next week. So if I'm asking an agent, now this agent needs to access a tool so it can provide you with an answer. Your prompt wouldn't help. Your prompt would be, I don't know, by checking the API of weather within this endpoint using this GET request, you can have like the weather from next week. And you're going to give it the API documentation. The tool you're going to give to the agent is basically a way to run like a command line interface where you're going to run the command that the agent is going to output. The agent is going to output the command. The request is going to be sent to the API. I'm going to have the response back. The agent is going to take the response and give it to the user. So it's not whether are you going to use a prompt or tool, but more of like the prompt should help your agent using the tool by itself. Okay. I hope that would be clear.
Okay. There is another question saying, how can we use AI agents to boost our productivity as developers?
Yeah, a great question. One of them is basically using GPT as it is now, although there is a sort of limitation on how many requests, but I think the daily use is good to use, the free subscription. You can go further and pay for the premium subscription. That would be even better. You can use Copilot, so you can boost your productivity if you are coding or VS Code or PyCharm, let's say, doing Python. You can even use Cursor now. So I saw many of my friends who are software engineers are using Cursor, depending on the company policy. If you are, let's say, freelancer, you don't care about your code base being exposed to external party, then you can use Cursor. If you are working at the company, take the permission of the company, of course. If they say no, then you can't, but you can use ChatGPT secretly. Yeah, I would say using AI-based code editor or AI-based coding tools. It's a great factor that would improve your productivity as a software engineer.
I guess this is it with the Q&A session. Well, as we reach the end of our talk, I take this chance to deeply thank Azzeddine Chenine for the incredible talk. It's been exciting to dive into how AI agents are driving the next wave of innovation. And of course, thank you to everyone here for your attention and participation. As we wrap up, I'd like to remind you about our next session, Introduction to Reinforcement Learning with Nazim Bandir, kicking off at 9 p.m. Make sure to stick around. It's going to be another great one. Thank you again and see you soon.
Bye-bye.